So at the beginning, again, if we're not really comfortable with logarithms, okay, and some of these values are a little bit difficult even if we're comfortable with logarithms, we might have to change things into exponential form to solve them. If we're going to change it into exponential form, we need this to equal something. So if I'm going to introduce a new variable, I'm going to have to say, I'm going to let x equal log 5 of 3125. Then if I change this from log form to exponential form, this equation is the same thing as saying the base is 5, the exponent is x, is 3125. And I don't think I put 3125 on your powers chart for 5. I think I went up to 625. But if you went one more, 3125 could be written as a power of 5. It's 5 to the 5. Do you remember this step? So, what's x? 5. I mean, if you can write them with the same base, then x would equal 5. So if you're really good at these, you could just say, okay, I know that logs solve for exponents. 5 to what exponent is 3,125? And if you recognize that as 5, you could have just said equals 5 right underneath, and you'd be done. Do you recognize the next one? 6 to what exponent is 1 over 216? Negative 3. Okay? So if you're able to do that right away, you could just go equals negative 3. And you're done, and that's fine. Full marks. If you can't see that right away, then you'll have to say, let x equal log 6 of 216. Change it to x, 1 over 216. Change it to exponential form. The base is 6, the exponent is x, equals 1 over 216. Look on your powers chart. Are 6 and 216 in the same column? Yes, they are. I can change 216 to 6 to the 3, then use my negative exponent rule to say 1 over 6 to the 3 is the same as 6 to the negative 3. So x would have to equal negative 3. Okay? And I think the last one is a great example of one that you can not just look at it and go, oh, I see what the answer is right away. This would be one where I would say it really makes sense to let x equal log base 8 of 2 cube root of 2. So change it to exponential form. The base is 8. The exponent is x. And we have 2. Are you all right if I change the cube root of 2 as 2 to the 1/3? Are 2's and 8's in the same powers chart? Yes. I can write 8 as 2 cubed. What can I do on the right-hand side? What's the rule when you're multiplying with the same base? Add the exponents. What's 1 plus 1/3? 4/3. You need a common denominator. And what's the rule for an exponent to an exponent? We multiply. So now we've got on this side 2 to the 3x, on this side 2 to the 4/3. So does it make sense that 3x has to equal 4/3? Divide both sides by 3 or multiply by a third. And x is equal to 4/9. Okay, try 4, 7, and 9.